You might have heard that light is actually, well, visible light that we see with our eyes is actually just one part of a larger spectrum that we call the electromagnetic spectrum. And so light is actually a kind of electromagnetic wave. And the different colors that we see of visible light are just different frequencies of that wave, of a wave. So red light, for instance, is a relatively low frequency for visible light, and blue is a relatively higher frequency. So similarly with like sound, with musical notes, you could have a fairly high note like this B. That might be similar to, say, like a blue light, relatively high, versus a pretty low frequency like this low E, relatively low, sort of like the red light. And similar to how sound waves, there's sound waves beyond these frequencies, there's also electromagnetic waves that are outside of the visible spectrum, right? Visible light is just one part of that spectrum. So for sound waves, maybe if you get much, much higher and higher frequencies of sound waves, then you eventually get out of the range that a human ear can hear. So something like a dog whistle is made to be a pretty high frequency, where dogs' ears can still hear that, but our ears can't. And the analogous thing for the color then would be like blue light is fairly high frequency, and then violet light is even higher frequency. And once you get beyond that, you get even higher, we start to get into what's known as ultraviolet light. It's out of the visible spectrum, but it's still light. It's still an electromagnetic wave. And if you keep going beyond that to higher and higher frequencies, then you get into sort of X-rays and gamma rays, right? All of those are still on the same spectrum. And on the other end of that spectrum, maybe you go from red light to even lower frequencies, which would be like infrared radiation, infrared light, and all the way down to very, very long wavelength, very low frequency radio waves.